10.4 Other angle relationships in circle. A few more theorems. There's going to be a lot of theorems to keep track of, so it's important to understand them and just make common sense out of them. And this theorem is about a tangent line, a line that intersects the circle in one spot, and a chord. And if you think about the complete measure of a circle is 360 degrees all the way around. Okay? That's 360 degrees. For an angle here, this is a straight angle. Is 180 degrees. So if we finish reading the theorem, then the measure of each angle formed is 1/2 the measure of the intercepted arc. So notice 360 degrees around, divide that by 2, you get 180. And this intercepted arc is also going to be half of, if we take half of it, we get this angle here, angle 1. So the measure of angle 1 is equal to half the measure of arc AB. Or likewise, the measure of angle 2, we double that, that would equal the measure of arc ACB, the major arc. Now notice either one of these formulas would work for either one, taking half of the arc or doubling the angle. So let's practice this. Find the measure of arc RST. RST. Well, if this angle is 102 degrees, we need to remember the circle is 360. This angle is 180. So if this angle is 102 out of 180, we double it, you get 204 degrees. And that makes sense because a semicircle is going to be 180 degrees. So we're a ways past a semicircle. So make sure you check your answer for reasonableness. The measure of arc RST, or excuse me, RT. Now there's two ways to do this. You could either do 360 minus 204, and you would get 156, or you could figure out what this angle is and double it. So this angle has to be 78, right? I took 180 minus 102 to get this angle. And then once I know that, I'd take 78 times 2, and that equals 156 as well. So either way, you get your answer, 156. Now, here's where it gets a little bit more complicated when we have, there's going to be 3 theorems, and it's going to talk about lines that intersect a circle. Okay, so the intersection can either be on the inside, outside, or on the circle. And we're going to talk about how these intercepted arcs relate to the angles formed in here. Now this is a little bit different. This is not a central angle, okay? Remember, that's not a central angle unless it's the center of the circle. It has to be at the center of the circle. So if I knew this angle, I don't just, the arc is not necessarily the same. But we're going to show some theorems here. And so the first one, not a central angle, so this angle and this arc are not the same, but rather it's going to be 1/2 the sum of the measures of the arcs intercepted. So to figure out what angle 1 is, the measure of angle 1 is going to equal 1/2 the sum. So now we have to figure out the sum. So the measure of arc CD plus the measure of arc AB. It's always good to check your answer to make sure it makes sense, because the next theorem is similar, but it's a little bit different. And this time, when they intersect outside the circle, now you could have this line as a tangent or going through here, but we're going to have to figure out what the measure of these arcs, okay, from here and here. And this time is 1/2 the difference of the measures of the subject. So this time we're going to take the measure, I'm going to have to get some more room, sorry. The measure of angle 1 equals 1/2 measure of arc BC minus the measure of arc AC. So very similar to the last one, except for this time we subtract the two arcs to figure out what that angle is. So to find the value of x, here the lines intersect on the inside. Notice this is not a central angle, so it's not 120 degrees. We have to use both arcs, okay, and it's going to be 1/2 the sum of those two arcs. So 160, half of 160 is 80 degrees. Okay, and my pictures aren't always the best trying to scale, but find the value of x. This time, all we know is that this arc from here to here is 80 degrees. And we're going to use that second theorem and first figure out what this arc is. Well, all the way around the circle is 360. So 360 minus 80 is 280. So this arc out here is 280 degrees. And this time we're going to take 1/2 the difference of the two arcs. So 280 minus 80. So that's going to be 200. So half of 200, x is going to be 100 degrees. Now here's kind of an interesting problem. You are standing on top of a hill, on top of a building or hill, 0.22 miles above sea level. Find the measure of arc CD. So we want to know basically how many miles can you see. Now, I don't know if you've ever been to, used to be called the Sears Tower, now it's the Willis Tower. If you've ever been there, they say, oh, you can see 8 different states from here or something like that. I can't remember the exact number, but it's a lot. You can see really far from the top of those tops of the skyscrapers. So how many miles is this? Could be a question you could find out, but we're just going to figure out the measure first. In a later chapter, we could take that arc measure and change it to a distance of how many miles you could see. But if I want to find this measure, I want to really find this angle. And now if this is 0.22 miles, and this is 3,950, segment BA, that segment's length is going to be the radius 3,950 plus that 0.22. That's going to be the length of that segment. So now I know two sides of a right triangle. I can use my trigonometry to figure out what this angle is. Okay, this is the center of the Earth. and this is the radius approximately of the Earth. So I'm going to label my sides. Here's my reference angle: opposite, adjacent, and hypotenuse. I know my hypotenuse and adjacent side, so I'm going to use the cosine of my unknown angle equals adjacent 3,950 over hypotenuse 3,950.22. Okay, so bring up the calculator. This calculator is not the best. I'm going to have to basically take the inverse to get x by itself. Cosine of this so I'm going to have to divide this out for this calculator first. 3950 divided by 3950.22. I get 0.088. Inverse cosine. I get an answer of 84. I'm not too... I don't think makes sense, so make sure I did everything right. That looks different. I think that must be better. I must have mistyped it. You guys got the inverse cosine. That makes more sense. Alright. It's not going to be a very big angle if you think about it. 0.604 degrees. Not even a whole degree, but that's just this angle. And the long-term goal is to find this arc. Well, this is going to be a central angle. So I have to double that to 1.208 degrees out of the total. So that's this angle now, doubled it. But this is a central angle, so this arc is going to have the same measure. Here's a kind of complicated problem. Try to go through it fast. X is going to be the average of these two arcs. But we don't know this arc, but we can figure it out. We know all the rest of the arcs. 170 and 30, that's 200. So 278 out of the total 360. Subtract these. I need a 2, that gets to 80, 82. So this arc is 82 degrees. So to find x, x is going to be the average. So I'm going to take 82 plus 30, and then take half of it. 112, half of 112 is 56 degrees. To find y, I need to know this arc, right? That whole arc, 82 plus 78, would be 160. And remember, total distance around is 360. Total distance here, or measure, would be 180, so I had to take half of the 160. So y is going to equal half of 160, or 80 degrees. There's your homework assignment. Stay classy, Lanesboro.